Class we have learned about motion along a straight line, what we call as rectilinear motion, types of motion, and then acceleration. And in this acceleration are of two types, and this acceleration two types means what, depending upon the sign of the acceleration, whether acceleration is positive or negative. Positive acceleration means what, change in velocity is positive. If it is acceleration negative, that means change in velocity will be what, negative. If the change in velocity is positive, means what, final velocity will be more than the initial velocity. Got it? So that means if the body moves very slowly, and after some times if it moves with a higher velocity, then that type of acceleration is known as what, positive acceleration. That means if it is going to be positive, what happened, this v must be greater than u. If it is going to be negative acceleration, then initial velocity must be greater than the final velocity. Suppose if an object keep on decreasing its velocity. At first it moves with a very high speed. At some later time, with the passage of time, if the body goes on decreasing its velocity, then that type of acceleration of that moving object is known as negative acceleration, and this negative acceleration is known as retardation. For positive acceleration, we simply call it as acceleration. For negative acceleration, we give a special name known as what, retardation. Clear? Now let's see those of the graphical representation of those motion. The first one is what, distance time graph. Distance time graph for that of uniform motion. So if we are going to draw distance versus time, then we need to know which one is what, independent variable, and which one is what, dependent variable. Independent variable means those variable which doesn't depend on any of the variables, okay? And what, dependent variable means which depends on some another variable. Now if a motion is taking place, then the distance moved or covered by the object depends upon time. As time goes on, what happens, distance will keep on increasing, because as the body is moving, okay? So what happens, this distance depends on time, right? So your distance is dependent quantity, and dependent quantity will always be drawn along y-axis, and independent quantity will always draw along x-axis. So for uniform motion, what happen, we know that as time increases, what happen, distance will keep on increasing. So what happen, these two are directly proportional. As time increases, distance covered or path length will also keep on increasing. So if one increases, the other increases. We call it that as directly proportional. So for such directly proportional graph, what happen, the graph will be a straight line. When I say graph, these are not the graphs, okay? These are axis, x-axis, y-axis. When I say graph, this curve, rather here in our case this is a line. So this line is known as graph. So for distance time graph, for uniform motion, the graph is a straight line passing through origin, okay? But to draw a graph, it is very easy. But from what can be concluded, what we can find from this what graph, that is very important. So now from this graph we can find what, we can find speed. How to find speed from this graph? If we know the slope of this graph, means the tangent of this angle, okay? In simple language, we can say how slant this graph with respect to x-axis, that we call it as slope in one sense. But mathematically, if this angle is denoted by theta, then what happened, tangent of that theta will be known as what, the slope. So let's see in the next slide how to find it out, and I will tell you there. Now we can say that this is what for distance time graph. For uniform speed or for uniform motion, it will be always a straight line. So the slope of this distance time graph indicates the speed of the body. What speed? Uniform speed of the body. Okay, so the distance time graph can be calculated. Okay, from the distance time graph, the speed of the body can be calculated. Let's try to find it out the slope from here. It can't come out. Yes, it is coming. Yes, now see, this is the origin, this is x-axis, okay, and this is your y-axis. And I have told you that dependent quantity distance that will be drawn along y-axis and independent variable time will be drawn along x-axis. So what happened? If you draw this distance time graph for uniform motion, then the graph would have been coming like this. As time, what happened, increases from here to here, then correspondingly from here to here, let's take it, then what happened, for this particular time, your distance, I mean the corresponding distance will be somewhere here, right? For this particular time, your corresponding distance will be somewhere here. Got it? So what happens, as time increases, distance increases, so you will get a straight line. So how to find what your speed or uniform speed? Got it? For this uniform motion, let's try to find out. You take a particular point A on the graph, okay, on the graph itself, and you draw perpendicular from this point toward x-axis and toward y-axis. You draw perpendicular like this. So this is perpendicular, or along x-axis the foot of the perpendicular is B, and along y-axis the foot of the perpendicular is C. So what happened from these, okay, distance OB and distance OC, this distance, I mean the length OC represent the distance, and the length OB on the graph will represent the time for this particular point. At this particular time, that means B, the distance moved from the origin is nothing but C. That means distance is what? OC. So OC divided by OB, we will call that as speed. So y speed is nothing but speed will be equal to what? Distance divided by time. So let's take it that speed is equal to what? Distance, let me write simply as d for distance, okay, and divided by what? Time. So this distance divided by time will give you what? Your speed. So distance in our case is what? OC, and time is what? OB. So if you can find out this distance divided by time, then you can easily find out your speed. And we can also take this angle, okay, angle formed by what? By this graph, okay, by this graph with respect to x-axis. Let's take it as theta, angle theta. So if you know this angle theta, then you can also find out this speed, this tangent of theta, okay, tan theta. Tangent of theta, we call it this as also what? Slope. Slope, SLOPE, okay, slope. So this tangent of theta, what we call as slope, is nothing but how slant this graph is with respect to this x-axis. If another graph is somewhere here like this, then that graph is having more slope than this graph. Okay, so by knowing such what slope, what we can find is what? The speed. Suppose these two graphs represents two what distance time graph for two body. Suppose one body represent this one, another body represents this one. That means this will represent the speed. What speed? Uniform speed of one object, and this graph will represent uniform speed of another object. So by not calculating from the graph itself, we can easily conclude that the object which represents this graph will have more speed, uniform speed, than the object which represents this graph. Got it? Like that we can find it out. So this tangent of theta means what? Tangent of theta means perpendicular by base. So perpendicular is what? AB, and AB is equal to what? OC. So AB divided by OB, that is known as slope, tangent of theta. Got it? So AB divided by OB means what? OC divided by OB. Why? Because AB is equal to what? OC. So your slope will be equal to what? OC divided by OB. Got it? Likewise, we can easily find out the uniform speed of what? Of an object moving with uniform motion, as well as we can also compare the uniform speed of what? Two or more objects from the distance time graph itself. Got it? Yes, let's see. This is what that I have told you. Okay, you can pause this video and you can see, or you can read whatever that I have told you in the previous slide. It will be all here. Okay, and for data of distance time graph for the object moving with non-uniform motion, then what happened? It will be a curved line. The distance time graph will be a curved line. It may be like this parabola, it may be okay curved downward, it may be curved upward, it may be of any shape. Got it? But I'm telling you, mind you, that the graph will not be a straight line. If the graph is a straight line passing through origin, then it would have been for uniform motion. Clear? It may be curved like this, it may be curved downward, it may be curved little bit like this, or it may be again moving upward like this, or it may be in this way, crooked line, not a straight line. It may be okay, or it may be curved upward like this. Got it? For this distance time graph, if it is curved upward, this is for an accelerated motion. Velocity or speed keep on increasing with time. If the speed keep on increasing with time, then what happen? With equal interval of time, speed means distance divided by time. So with equal interval of time, what happen? Distance will keep on increasing rapidly. So what happen? Your distance time graph will be curved or move upward in the graph. Okay, yes, this is also all about that I have told you. It is of no so important, but you can see the whole writing there. By pausing it, you can read it. Okay, just read it. But not to take much of your time, let me skip this and let me go to the next one. Okay, right, let's see for the next slide. What we can conclude from the above discussion, let's see. If the distance time graph for of a body is a straight line, then its speed is uniform. In that first graph, we found that distance time graph is a straight line, and that straight line is for uniform motion. If the body is moving with uniform motion, then the body should move with uniform speed. Uniform speed means equal speed. So if the distance time graph of a body is a straight line, then its speed is uniform. Got it? If the distance time graph of a body is a curved line, then it will represent what? Non-uniform motion. We have already learned this one. We know that when a body moves with non-uniform speed, then its motion is said to be what? Accelerated motion. Acceleration may be of two types, as I told you, that it may be positive or negative. Okay, so the curved line OA in figure C, in that last figure, what happened? The curved line OA in figure also represent the distance time graph of a body moving with accelerated motion, because the graph was curved, right? Yes. If the displacement time graph is drawn, then it will specifically represent velocity. When we say distance time graph, that was for speed. Got it? Speed means it has no direction, but when I say velocity, it has a particular direction. So instead of distance, we will say as displacement time graph if we are going to represent for velocity. If the body keeps on moving in a particular direction, then distance time graph and displacement time graph will be same, and the magnitude of velocity and the magnitude of speed will be also same. Why? Because the magnitude of velocity will represent nothing but the speed, if provided the body or object moves along a straight line. Got it? For example, if the displacement time graph of a moving body is a straight line, then it represents uniform velocity of the body, as I said. Clear?